Hey everyone, Dave here. This mini lecture is on law of conservation of mass. I will try to put in little summaries here for you, which are really the key points of whichever mini lecture I'm delivering. Now, before we start looking at the law of conservation of mass, I just want to get something else out the way, and that's what happens when you write out what's happening in a chemical reaction. Just a couple of points on terminology. When things react in reactions, they're referred to as the reactants, and of course they're then changed into something because they've reacted, and those things are called the products. So here's an example. We've got two reactants here. We've got carbon and oxygen gas. So they're reacting. That arrow there means reacts, and they're forming this product here. In this case there's only one product, and that product is carbon dioxide. So if you look at this equation, the way you'd read it in your mind would be carbon plus oxygen gives or reacts to form carbon dioxide. And there's just a little summary there for you. The carbon and the oxygen are reactants, and they're reacting to form those products. Okay, now that we've got that out of the way, we can actually look at this thing called the law of conservation of mass. So what does it say? It says that matter is neither created nor destroyed, or mass is neither created nor destroyed, or in a chemical reactions, atoms are neither created nor destroyed, they're simply rearranged. In other words, whatever type and number of atoms you start with in the reactants, you have to end up with precisely the same number in the products. So if you take that on board and you look at this particular chemical reaction, you can see that there's actually something wrong with it. So what's wrong with it? Well, if you, let me get my pen here, if you look at this reaction and you look at the number of atoms involved, here we've got two hydrogens. Obviously this starts off with this, like this. Whoops, not too good, but anyway, there you go. So we've got our hydrogen molecule here. It's reacting with our oxygen molecule, which has got two atoms of oxygen. Join with oxygen, oxygen double bonds like this, and we're forming, of course, this thing here, water. Okay, and now I think you can immediately see the problem. On the left-hand side of the equation here, we've got two atoms of hydrogen. On the right-hand side, we've got two atoms of hydrogen, so that's all good. But here on the left-hand side of the equation, we've got two atoms of oxygen, and on the right-hand side, we've only got one atom of oxygen. So it's like one atom of oxygen's disappeared after the reactions occurred. Now this can't happen because it violates this law of conservation of mass. That is, I started with two atoms of oxygen here. I've got to end up with two atoms of oxygen over here. Alright, so what's really going on? Well, what's really happening is this. We're actually starting with two molecules of hydrogen there, so two H2s, and they're reacting with one molecule of oxygen here, and they're forming two molecules of water. Now if you look at that reaction, you'll see that this is consistent with the law of conservation of mass. Let's go through it. So here we've got 1, 2, 3, 4 hydrogens on the left-hand side of the equation. Here we've got 1, 2, 3, 4 on the right-hand side of the equation. There it is summarized there. And of course we've got two oxygens here and two oxygens here. This is referred to as a balanced equation because it hasn't actually violated that law of conservation of mass. Now you might think, if I just zip back here, you might be tempted to say, well, alright, what I can do to fix up this equation is, if I get my pen out here, I'll just go with a black one. What I might want to do is put a 2 here, like that. Now you can't do that because you've actually changed the compound. We are saying here that these two things are reacting to form water, not H2O2. This is actually a completely different compound. Okay, that gives you an idea of the importance of the law of conservation of mass, how we get around this problem of trying to balance up the equation so that it doesn't violate that law. That's what will happen in the next mini lecture.